Welcome to Solution Chemistry. We are beginning our unit on solutions, and we are specifically going to look at the definitions of a solvent, solute, solubility, and solution, talk about the difference between a hetero and a homogeneous solution, look at the three different solute-solvent combinations, as well as discuss the difference between an electrolyte and a non-electrolyte. So let's go ahead and move on and talk about what is a mixture. And you can remember here that we have a mixture is two or more materials that can be physically separated. The mixtures that we can see the different components of, again, that they are heterogeneous or heterogeneous, and again, it's different is the key word there. And then mixtures that are the same is homogeneous, and that's the same is the key word there for homogeneous. Well, what is a solution exactly? And well, a solution is specifically, it's a homogeneous mixture of two or more substances that is uniformly, so evenly distributed or dispersed throughout a single phase. So down here we're taking two examples, milk and salt water. We're looking at this solution, and although milk, it may look like a solution, if we actually look at it really close, you can see lipid droplets in the milk. That is just really fat that is inside the milk, and they're actually kind of more suspended in throughout the milk than they are really dissolved throughout the milk. Whereas salt water, it's more of a specific solution, and the reason that it's a solution here is that the sodium and the chlorine ions are completely dissolved in and amongst all of the other water molecules. So that this really is making it a homogeneous mixture, which again is a solution. So a solution, you need to understand here what a solution is, that it has a solvent, which is the greater percent and what does the dissolving, whereas the solute is the less percent or what is dissolved. So an example here is salt water, where solvent is the major part of the solution. Usually it's going to be water, and solute is what's being dissolved, so the part that is being dissolved. So these are two very important concepts to make sure that you get down and understand for solute and solvent definitions. There's also some different types of solute-solvent combinations that we can have, and it's really the three states, gases, liquids, and solids, can all be put into, they can all dissolve in one another. So gases, as a solute, can actually dissolve in other gases, such as oxygen in the air. We also have gas solutes and liquid solvents. So gases can dissolve, like CO2, can dissolve inside of a soda drink or a carbonated drink. We have liquid solutes that can dissolve into gas solvents, such as water in the air, which is going to be your water vapor in the air. Liquid solutes in liquid solvents, so liquid and liquid, obviously we can dissolve things like rubbing alcohol or something in water. And then we also have liquid solutes and solid solvents, where we have mercury and silver in tin. So that's kind of where we get our dissolving a liquid mercury here into a solid metal. And then our solid solutes in a liquid solvent, which is salt in water. Solid solute in a solid solvent, such as silver and gold. This is more specifically known as an alloy. When we dissolve one metal in another metal, we kind of melt them down and put them together, as an example there with your ring. Here's a table that would be beneficial to look at the solute, solvent, and an example here. I would know these examples as possible, like test-like questions that you should get down. And some more specific examples down here, if you want to fill in that table, would be beneficial for you to have here, looking at our solution, solute, and the solvent, what's making those up. So an example there of like air. A lot of people don't know air is a solution. It actually is 78% nitrogen, roughly about 22% oxygen, and then the trace other gases such as hydrogen and CO2. But the main part of it is nitrogen. And then the last thing we want to talk about is an electrolyte versus a non-electrolyte. And we're going to watch a short video clip here to determine what an electrolyte is versus a non-electrolyte.
An electrolyte is a substance that, when dissolved in water, results in a solution that can conduct electricity. The light bulb will light if a substance is an electrolyte. Sodium chloride, NaCl, is a soluble salt that is assumed to completely dissociate into ions. NaCl is a strong electrolyte when dissolved in water. The solution contains a large number of ions, and the light bulb is brightly lit. Polar water molecules interact with the positive and negative ions of the salt. The positive ends of the water molecules are attracted to the negative chloride ions. The negative ends of the water molecules are attracted to the positive sodium ions. This interaction between the water and the salt ions causes the salt to break apart or dissolve in water. Hydrofluoric acid, HF, is a weak acid which only partially ionizes in water. HF is a weak electrolyte. The solution contains only a small number of ions, therefore the solution is weakly conducting and the light bulb is dimly lit. At equilibrium, a hydrofluoric acid solution contains mostly non-ionized acid molecules, HF, and a small amount of hydrogen ions, H+, and the conjugate base ion, F-. Methanol, CH3OH, does not dissociate into ions when dissolved in water. It is a non-electrolyte. A non-electrolyte solution does not contain ions. Therefore, the solution does not conduct electricity and the light bulb does not light. Methanol molecules contain a polar OH group. The oxygen has a partial negative charge and the hydrogen has a partial positive charge. This charge separation is called a dipole. Methanol molecules are attracted to each other through the interaction of the dipole of one molecule with the dipole of another molecule. Water is also polar and the dipole of water will interact with the dipole of methanol. These particular dipole-dipole attractions are called hydrogen bonds. The attractions between water molecules and the methanol molecule will break the attractions between methanol molecules, causing methanol to dissolve in water. Note that upon dissolving, the covalent methanol molecules remain intact. Compare this to the dissolution of an ionic compound such as sodium chloride, NaCl, which breaks apart into its component ions in water.